Hello everyone, this is Dr. Lennon, and today we're going to look at combining functions. So there's two main ways that we're going to look at. So the first set is kind of the ways the more obvious and less important of the two. So this is kind of arithmetic combinations of functions. So this is essentially just making new functions out of your standard operations: add, subtract, multiply, and divide. So let's start by saying we're given two functions. We need two functions to combine them. So given two functions, let's say f of x and g of x, we can form four new functions. So the first one, we'll name it f plus g of x. And that name is just to let you know that it's done in the obvious pointwise fashion of adding f of x to g of x. Similarly, we can name a function f minus g, and that is done with the pointwise subtraction, f of x minus g of x. We can also use multiplication, f times g, and that's going to be f of x multiplied with g of x at every single point in the domain. And the last is division. So let's say f over g of x. This would be f of x over g of x, provided g of x is not equal to 0. So anywhere where g of x is equal to 0 would not be in the domain of this new function f over g. So there's a bit of a domain constraint on forming that new function. So let's go ahead and look at one example of applying this. A lot of times this is just so obvious, this combination of functions, that it's not even really talked about too much. But it's good to at least reflect on it for a moment. So let's start with two functions. Let f of x equal 1 divided by x minus 2, and g of x equal the square root of x. So let's start by finding all of those four functions. Find f plus g, f minus g, f times g, and f over g. So we're just looking for the formulas of those four functions. Why don't we, while we're at it, also find the domains. So f plus g of x is found by just adding their formulas together. 1 over x minus 2 plus the square root of x. The domain of this function, notice x cannot equal 2, and also because of the division by 0 caused in the first term, and from the second term, we know that x has to be greater than or equal to 0. So the domain, we need x cannot equal 2, and x has to be greater than or equal to 0. So in interval notation, this would look like 0 to 2, unioned up with 2 all the way to infinity. So that would be the domain there. And then f minus g is not going to be too much different. In fact, it's going to be exactly the same domain, and the formula will be similar. It's just going to have a minus in the middle. So f minus g of x is going to be 1 over x minus 2 minus the square root of x. And the domain of this function, as mentioned, is going to be exactly identical. So I'm just going to copy down the interval notation. So f times g, not especially interesting either. 1 over x minus 2 times the square root of x. which we could simplify as the square root of x over x minus 2. And again, the domain would be exactly identical. So the domain here is still, as before, 0 to 2, union 2 to infinity. And in the very last one, we need to do the division. So we have f over g of x, which is 1 over x minus 2, excuse me, divided by the square root of x, which is the same as multiplying by the reciprocal, so that's 1 over x minus 2 times 1 over the square root of x, and that will put that square root of x on the denominator. So now we see we are going to have something that's going to affect the domain a little bit. Now x equals 0 would also cause division by 0. So the domain switches slightly. What we need is we need x to not equal 2, and x can also not be 0. So x has to be strictly greater than 0. So the domain changes slightly to 0, 2, union 2, infinity. So we have a slight difference there. Okay, so that's it for part A. Now let's maybe evaluate the functions. So B, evaluate each new function at x equals 4. So we have f plus g of 4. This is going to be f of 4 plus g of 4, which is 1 over 4 minus 2 plus the square root of 4. So that's going to come out to 5 over 2. And we also have f minus g of 4, which is f of 4 minus g of 4, which would be exactly the same as the above, except for now we're subtracting the square root of 4. And this comes out to minus 3 over 2. And then we have f times g of 4, which is f of 4 times g of 4, which is going to be 1 over 4 minus 2 now times the square root of 4. And this comes out to 1. And then lastly, we have the division. So we have f over g of 4, which is f of 4 over g of 4, which is 1 over 4 minus 2 divided by the square root of 4. And this comes out to 1/4. So that is applying all of those functions at a single point. And again, that's all we're really doing is applying each function separately and then combining them using whichever operation is indicated by its name. So now we're ready to move on to the more interesting way of forming new functions, which is known as composition. So this is really kind of substituting one function into another. So composition of functions. So the idea is substituting functions as inputs into new functions. So we could say given, and we have a special notation for it that's often used. So given two functions, let's say f of x and g of x. So 1, so this is f with a little circle and g of x. This is known as f of g of x. That's how this is read. So this is read f of g of x. And that's not multiplication, that means compose. So that means what we do is we take all of g and we plug it in as the input of f. And for 2, it would be the reverse. You could do it the other way, g of f of x. So this is g plugged in, this is f plugged into g. And again, this one would be read g of f of x. So let's go ahead and see how some of these things work. So example, let's go ahead and let f of x be the formula x squared, and g of x be equal to x minus 3. Okay, so A, let's go ahead and find f of g and g of f and their domains. So since we're dealing with two things that are both polynomials here, it's very unlikely we're going to have any domain issues. So you might already see that or guess that the domains of both of these are just going to be all real numbers, which is going to turn out to be true. But let's go ahead and look at the formulas. F of g of x means we want to do g of x plugged in as the input to f. So g of x is x minus 3, so we want to replace x in the f formula by x minus 3. So we look at the f formula and change every occurrence of x to x minus 3. And again, this is just a polynomial, and we know polynomials have domains all real numbers. So the domain here is all real numbers or negative infinity to infinity if we're using the interval notation. Second infinity is kind of sloppy. And then we can do g of f of x. So this one, we're plugging f as the input into g. So that just means anywhere we see x in the g of x formula, we're going to change that x to x squared. So this just comes out to x squared minus 3. So notice these two things are not the same. Of course, this is, you would have to FOIL it out, but it would be x squared minus 6x plus 9 if you wanted to expand that polynomial. But again, the domain here is going to be all real numbers again, because polynomial functions always have domain all real numbers. So that's it for part A. For part B, let's talk about just finding some values, some pointwise values. So let's find, let's say, f of g of 5 and g of f of 7. So you can do these in 2 steps or do them in 1 step, but basically we have to plug, for the first one, f of g of 5, we have to plug 5 into the formula for g, and then plug the result of that into the formula for f. So g of x was just subtracting 3, so 5 minus 3 is going to be 2. So this becomes f of 2, and then the function f just squares that, so we get 4. And the right-hand side, g of f of 7, this means plug 7 into f, and then plug that result into g. So again, f just squares the number, so this is going to be g of 49, and then g just subtracts 3, so this is going to be 46. All right, so you can kind of think of this visually as being plugged into 2 consecutive kind of machines. So the left-hand side here, we start with 5. It goes into the G machine and gives us the result 2. And then we plug 2 into the F machine, and F gives us the result of 4. So that process is the f of g. And similarly, we can see the same thing here. 7, in this case, first gets plugged into the F machine and gives us 49, and then that result gets plugged into the G machine and gives us the result 46. So you can think of that kind of as a diagrammed view of what is happening. So let's go through one more example, maybe where we have something interesting going on with a few more functions. So let's say we have let f of x equal the square root of x and g of x equal the square root of 2 minus x. So let's find each composition and the domain. So once you have square roots or division involved by variables, then domains are going to get more interesting. So let's say we have f of g. Okay, so for this one, we have f of g of x. So this is g plugged into f, which should be f of the square root of 2 minus x. And then f just takes the square root of that, so we get the square root of the square root of 2 minus x. And if you want to use exponent rules, this is 2 minus x to the 1/2. And then that whole thing is raised to the 1/2. So actually this is 2 minus x to the 1/4. Or you could think of this as being the 4th root of 2 minus x. Now, the domain here, we know that we need, if we have a 4th root, we need 2 minus x to be greater than or equal to 0. So the domain here is found by just solving the inequality 2 minus x is greater than or equal to 0, which says 2 is greater than or equal to x. So that domain is just negative infinity all the way up to 2. So that's the domain we get for part A. Let's go ahead and do B. Let's do the reverse composition, g of f. So this would be g of f of x. So that is now f plugged into g. And f was the square root of x, so we're doing g of the square root of x. So that means we need to plug the square root of x in where x is in the f formula. So that's going to be the square root of 2 minus the square root of x. So that's a pretty interesting formula. So the domain, we have two things that we need to happen because now we have the square root of x inside there. So we need x to be greater than or equal to 0. And we also need 2 minus the square root of x to be greater than or equal to 0. So we have to solve this inequality. So this would say 2 is greater than or equal to the square root of x. And then we could square both sides. So squaring both sides yields 4 greater than or equal to x. So if you think about both of these graphs and then combining them, since it's an and, it has to be their intersection. So we could graph both parts if we really wanted. We have 0. So x has to be bigger than or equal to 0 and also less than or equal to 4. So the first greater than or equal to 0 would be shading, let's say, to the right, and less than or equal to 4 would be shading at 4 and to the left. So the domain would be the part that is colored both, with both colors, both red and blue. So the domain here should be just from 0 to 4 inclusive. Okay, so let's go ahead and try one more. Let's go ahead and do something that's a little bit tricky. Let's try to do g composed with itself. Can we do g of x? So if we're composing g of g, this is just g plugged into itself. So g of x is g plugged into itself. And the formula for g is the square root of x of 2 minus x So now what we would do is we would replace the x that we see above just with itself, the square root of 2 minus x. So this should come out to the square root of 2 minus the square root of 2 minus x. So we have some nested radicals there. So if we want to think about the domain, what needs to happen? Well, let's investigate by looking into the furthest radical, 2 minus x. So we need 2 minus x to be greater than or equal to 0, certainly. But we would also need the whole thing, 2 minus the square root of 2 minus x, since it's underneath a radical as well, to be greater than or equal to 0. So we can solve each one of these things. So the first one is quite easy, just add x, and you have 2 greater than or equal to x. And then the second one, we could add the square root of 2 minus x, and then square both sides. So we'd get 4 is greater than or equal to 2 minus x. So we subtract 2, we get 2 is greater than or equal to minus x. And then we have to multiply or divide by -1, which means we have to switch the direction of the inequality symbol. So we have -2 is less than or equal to x. So again, we can draw this and shade both parts. So we have our 2 and we have our -2. The first part, x has to be greater than the first part to the left, 2 is greater than or equal to x. So x has to be smaller than 2. And then the right part says x has to be bigger than -2. So the domain here is going to be, again, whatever is shaded twice, which is -2 to 2. So that is our domain for part C here. So that's it. So domains can be a little bit tricky, but the idea of plugging stuff in is pretty natural. Substitution is a common thing. And you'll see a few more answers on the homework, so we'll do some examples there as well. Anyhow, this is Dr. Linden signing off.